Welcome once again to Competency Mathematics, where we make mathematics easy. So in this particular video, I'm going to show you exactly how a grade 7 mathematics full examination looks like. And actually, we are going to start right away. So kindly do stick around with me as we tackle through each and every question together with you. And we have our first question right here with us. And we are told that a certain dam has that figure liters of water. And then we are asked to find, or rather the question goes ahead and tells us what is the value of digit 5 in the number. So the question is asking us to find the place value of digit 5. And actually, this is a question that rarely misses in examinations, because quite often in question 1, you'll find a question asking you about writing numbers in words or place value. Therefore, it's very important that you do understand how to find the place value of a number. So this number looks quite huge, and so that we can be able to visualize it quite clearly, we are going to write it right here. Again, we have 8, 5, 1, 6, 2, 7, 3, 0, 9. So the first thing that we do is to try and locate where 5 is, and we can see that 5 is right there. So we go back to the question. The question is asking us to find the place value of this digit, which is right here, which is 5. How do we go about that? So to be able to find the place value of digit 5, what we do is that we find the place value of each and every number that we have, but now we start from the right hand side as we move towards the left hand side until we reach where 5 is. And actually, let's go ahead and do that. So we have our first number from the right hand side, which is 9. So the place value of 9 is ones. The place value of the second digit is tens. The value, rather the place value for digit 3, after we move from ones, tens, we move on to hundreds, and then we move on to thousands. From thousands, we move on to tens of thousands. After tens of thousands, we move to hundreds of thousands. After hundreds of thousands, that's now when we move to millions. After millions, we move to tens of millions. I'm writing this in short form because the space might not allow me to write it in full. But now we are able to locate that after we follow through this process, we are able to get to a point where now the place value of digit 5 is tens of millions. And once we have it right there, we go back now to our choices and see whether we've got any answer that is commensurate to this one. It's not millions, it's not 500,000, it's not hundreds of millions, but it is tens of millions. And if you do that, then you should be able to get your mark for that question. But the most important thing here is to ensure that you do not confuse the place value and total value of numbers. And the second thing, which is very important, is to ensure that you do count the place value of numbers from the right as you move towards the left, and also to ensure that you key in each and every number, because if you leave out a certain number, then you are likely to make a mistake along that line. So let's move on to the second question that we have. Remember, this is a full grade 7 mathematics full examination. So we are told in this question, write the following number in symbol. And the number is 777,707 and 77 hundredths. So let's go ahead and try to write out this number. So the first thing that we do is that we look at these particular words that we've been given here until the place that we've got a comma. So the number that we've been given here is 700 777. You know, it is quite easier to write 777 because you know that 777, we simply write it like this, 777. But now the question is telling us that this is 777,000. Therefore, this is thousand, and thousand have got 3 zeros like that. So let's go ahead and see what the question is telling us. So we have a comma, and then we are told 707, 707. So 707, we simply write it like that, 707. You know, this question might appear to be tricky by the fact that we've got a lot of sevens. So it's important to know the difference between these, and these. You see, this is 777, this is 707, and this is 717. Therefore, ensure that you don't get tricked with that. But let's again go ahead and read the final part of the question. So we have 777,707, and finally the last part we have 77 hundreds. You know, hundreds implies that that figure has been divided by 100. So if this is 77, therefore it implies that it is 77 that has been divided by 100. And if you are to take up these decimal places, you are supposed to shift 2 times the first time, the second time there, until you get 0.77. Therefore, this one is read as 77 hundredths. Therefore, we go ahead and write that 0.77. You see this one, it should appear on the decimal side because it is not a complete whole number and it is hundreds. Therefore, it should appear there. So finally, we get to sum up and put up our number together. We have this is 0.77 and we have this is 7 there. We have a 0. You have to be careful again so that you don't make errors. Remember that as we deal with numbers, what we usually say is that you should pay attention to speed and also at the same time accuracy that you withholding. So this is the final number that we get, that is 777,707.77. So we can separate this one into 3 numbers so that we can be able to visualize well. So we'll have 777 and then 707. I see this one is not matching with that. This one is not matching with that. What about this one? It's not matching with that. But what is matching with that is this figure right there. And that therefore becomes our answer. But if you look at these other options that we have here, they can be quite confusing by the fact that they have got a number of zeros there. But it's important to know how to read these other figures as well. For instance, this one is 707. You see, this one is 707. But what we have here is 777. Therefore, that is what makes it not to be an option. And for this one, what is the mistake with this one? You see, this one is 770. This is read as 770,000, but this one is 777. Therefore, it misses a 7. For this one, we count it off because what we have here is 700 and 7. This is 707, but this one is 777. Therefore, the correct solution for that particular question is this figure that we have right there. With that, let's move on to our third question. So we have it right here with us. We are told round off the number 516,636,484 to the nearest millions. This is a very important keyword there because it is what is going to guide us on what we are going to do. So we have to the nearest millions. So to be able to round off this number to the nearest millions, we should be able to know where millions lies in the place value of millions where it is. Remember that this is just the units digits, this is the thousandth digit, and this is now where the millions start, because we have these ones as ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands, and millions is here. So what we do is that we place a line, or rather a mark, just after the millions place value right there. That is where we place a mark, and then we go ahead and make our judgment. So to be able to round it off, what we usually check is the number that appears right after our mark. You see, this is where we've placed our mark. And remember, the mark that we are placing should be after the millions place value. Immediately after that. So the next thing that we do is we consider the number that appears immediately that. And what we usually do is that we check whether that number is 5 or more than 5. If that number is 5 or more, what we usually do is that we usually add 1 to that number, and then we usually add 1 to the number that is immediately before that mark, and then we make everything else that follows that number to be 0. Therefore, that implies that what will appear after all this, it should be a 0. And actually, let me put it right clearly for you. This is where we have our mark. So what appears immediately after the line should be converted all of that to 0 and to 0 to 0, like that. So what we have here, we are going to get 0 0 0 0 0 0, and what we have here, this is going to be converted to 6 plus 1, that is 7, and we have now everything else remaining the same. We have 5 and 1. So finally what we are going to get there is 5 1 7, and then we have 0 0 0 0 0 0, and what we read, this is 517 million. So because now you see it is nearest to millions, therefore right after the millions place we should not have any other digit other than zeros. And we now check through our options that we have, and definitely we've got an option right here, which is 517 million, and that is how we are able to round off that number. So with that, I believe we can proceed on to our fourth question, and I believe that this is becoming a bit more interesting as we also get to tackle along. Remember that this is a full grade 7 mathematics full exam. So we are told in question 4, what is the total value of 8 in the number? What is the total value of 8 in the number? You remember we started by finding the place value, but now what we have here in this question is now the total value. You should be able to distinguish between the two. That is the total value and the place value. You see, the place value shows you the position of a number, or rather the position of a digit in a number. It shows you just the position. This position is tens of millions. But now for the total value, it shows you the value, the number, the digit, or rather the value the digit contributes to that number. Therefore, it's important to be able to distinguish between the two. The place value, it is showing you the position of the number, but the total value is showing you the value that that digit contributes to that number. So the easiest and the fastest way to do that is to pick that particular value that you are asked to find its total value, and then you write it down. For instance, for our case that is 8, and then if there is a decimal, you write it first so that you don't forget about it. And then where there are any gaps, like at this place where there was a 3, you replace that with a 0. And then just before that, you replace the entire number with a 0. I hope that that was pretty quite easy and straightforward for you. That is, you start by writing down the number that you're asked to find its total value, just exactly at the position where it lies. And then if there is a decimal, you indicate where it is. And then in between, if there were any numbers, you replace that with a 0. And that is exactly what we've done. And that gives us 0.08. So it's not 0.09, it's not 15.08, it is not 0.8, but it is this value that we have right there. You'll notice that it is very easy to make a mistake as you do this, because there's a likelihood that you can forget to write this 0 that is right there. Therefore, it's very important that you pay keen attention and focus as you get to write down the numbers as they are. But that was it for question 4. Let's move on to our next question. And remember, these are questions that are usually tested quite often, and they rarely miss in grade 7 examinations and even in consecutive examinations for KJSEA. So let's move on. In question 5, we've got a very interesting and a very wonderful question here involving fractions. We are told work out 8 over 11 minus 2 over 7. So that's what we are supposed to work out. So the first thing that we do is to check whether the denominators are equal. The denominator, that is a number that appears below the fraction. And the first denominator that we have is 11, and the other one is 7. So these denominators are not equal. Therefore, we cannot go ahead and subtract directly. You see, if we do 8 over 11 and we are told minus 2 over 7, it is a mistake to say that this is 8 minus 2, then you write 6, and then you say 11 minus 7, you say that that is 4. This is totally wrong. That is totally wrong. Why? Because the denominators are not equal, and this is a mistake that is usually made by a lot of people. But if it was something like 8 over 2 minus 6 over 2, then this would be correct to say that it is 8 minus 6, that is 2, and then we retain the denominator. This would have been correct. But now, for this case, the denominators are not equal. So what do we do? For a case where the denominators are not equal, we find the LCM of those denominators. For our case, we have 11 and 7. See, these are prime numbers. They cannot be divided by any other number. Therefore, the LCM is simply 77. And this is actually straightforward trick to find the LCM of prime numbers. Whenever you've got some prime numbers that are numbers that are not divisible by any other number, how you get to find the LCM is that you just simply get to multiply them to get the LCM. For this case, we multiply 11 by 7, and that is going to give us a 77. So let's go ahead and work out the question. So we have 77 divided by 11, that is going to give us a 7, and then we pick that 7, we multiply by 8. What is 7 times 8? That is going to give you 56. And then you minus, we go ahead, we have 77 divided by 7, that is going to give you 11, and then you multiply 11 by 2, that is going to give you 22. And then you go ahead. Now it is safe for us to do this subtraction that is right here. We have 6 minus 2, that is 4. We have 5 minus 2, that is 3. And we have 77 right there. Amazing. So that's the solution that we get for that. But then again, before we go ahead and check whether there's a value that is matching with this, we look at this value keenly and check if we can be able to simplify it further. Do we have any number that can divide 34 and 77 equally? But what I see is that there is no such a number that can divide 34 and 77 equally. Therefore, that is the final solution for that. And I believe we have it right there with us, and that is the required solution for that question. So with that, let's go ahead and check our question 6. Our question 6, we have it right there, a very wonderful question as well. We are told what is the square of 11 over 12? So we are supposed to find the square of this number. Quite often, there is an error that is usually made by a lot of students as they get to work out this. And to point out, so that you don't get to make the same error again, when you have such a number, 11 over 12, what you are supposed to do is that you are supposed to take the whole of it. That is the whole of the numerator. If it is 11, you multiply 11 by 11. And the denominator, you multiply it the same way. It is 12 times 12, like that. You see, quite often you'll find like their students will pick 11 times 11 and then they find the answer for that. And then they just simply leave 12 the way it is, which is totally wrong, and that shouldn't be. So what you're supposed to do is that you're supposed to pick, if it's 11 multiplied by 11, let's go ahead and do that. So if you are unable to multiply that often, you can just use the long way, which you say that this is 1 times 1, 1 times 1, 1 times 1, and 1 times 1, and then you get 1 to 1. But I believe you know the shortcut for multiplying a number by 11. Usually pick, if it's 11, you pick it 1, 1, that is 11, and then you add 1 plus 1, which is 2, 1 to 1, which is equivalent to this one. So whichever method you use, it's all right. It all depends with the method that you find convenient as you do that. So 11 times 11, we write there 1 to 1, like that. We go ahead and do 12 multiplied by 12. For that, you can be able to do it often, but then again, if it's an issue doing that, there is no any harm using the long multiplication method, where you say that this is 2 multiplied by 2, which is 4, and this is 2 by 1, which is 2, this is 2 by 1, which is 2, and this is 1 by 1, which now gives you 4, 4, 1, 4, 4, which gives you 144. So this is the required solution for that particular question, and that is how you are really supposed to solve it out. But then you see, this part right here, 121 over 144. Do we have such an answer? Yeah, we have it right there, and that is the solution. So here is where the mistake applies. You see, we have 11 over 12 that we are supposed to find the square. So you'll find there's someone who will pick 11 plus 11, and then they pick 12 plus 12, and then they say this is 11 plus 11, 22. This is 12 plus 12, that's 24. And you'll get an answer for that right here. But this is very, very wrong. That shouldn't be the case. There'll also be another person who will pick 11 over 12. We are finding the square of this, and then they'll pick 11 times 11 over 12, and then they'll say this is equals to 121 over 12. But this is again very wrong. You see, you'll get an answer for that right there. And also there's a person who will just square the denominator alone, and they forget to square the numerator as well. So to be able to get that correctly, you should be able to square both the numerator and the denominator for that, so that you're able to get a correct solution for that. So with that, let's go ahead and check out the next question, and remember these are questions that are highly tested quite often. Oh, you see, the question that we have just done was involving finding the square, but now the question that follows is asking about the square root. Let's go ahead and check it out. We are told find the square root of 2 over 49. So how do we get to find this? So here we have got quite a repetition. Let's assume that we are not supposed to have this word. It's just supposed to be find the value of, so that we don't have the repetition of a square root. But the idea is that we are supposed to find the square root of this number, that is 2 over 49. You see, it is quite hard for us to find the square root of this number when it is like this. So you should be able to convert it into an improper fraction. And how we do that is that we multiply 49 by 2. That gives us 98. And then we have 98, we add 2. That is going to give us 100. So you'll notice that 2 over 49 is equivalent to 100 over 49. Since we had a square root here, we should have a square root there as well, like that. But now we know that when we've got a square root of a number like 100 over 49, what we do is that we find the square root of each and every number as it is. So we find the square root of 100, and also we find the square root of 49. This one, it is quite easy to be able to tell what is the square root of 100, because we see that we have got 2 zeros. Therefore, the square root of this number is just a 1 with 1 0, which we call 10. And then for this particular part, that is 49, the square root for that should be a 7. So we have 10 over 7 like that. So that should be the solution for that. But then again, you can see that this was in a combined fraction. Therefore, you should be able to put it in the same format as well. So if we are to put it into this format, therefore we should know that 7 goes into 10 only one time, and then we remain with 3 over 7. 3 over 7 like that. And this is an equivalence of this, and that is what you should have. And then we check whether we've got such a sum that is matching with that. And from what we have, that's not matching with that, not matching. What we have is this value that we have right there, and that becomes the solution for our question, and that is exactly how we were supposed to solve that question. So with that, let's move on to our next question and see what the question is asking us about. So we are told in our question 8 that the length of classroom is r centimeters. So let's assume that this is the classroom. This is just a sketch, it's not accurate, but we are told that this length is r centimeters, and then we are told that the width is 5 centimeters shorter. 5 centimeters shorter. So if it is shorter, then that implies that this should be r minus 5, because it is shorter. Shorter implies lesser. Shorter implies that it is that figure that we've been given minus what follows after that. So we are told that the width is 5 centimeters shorter. Therefore, it is less than 5 centimeters of what the length is. Let's go ahead and see what the question is telling us to find. We go ahead and read. We are told, write an expression to represent the width of the classroom. And actually, I see that we already got that already. R minus 5, do we have such a case? Yeah, we have it right there. And that is the required solution for that. Oh, this is becoming a bit more interesting. Let's check in our question 9. We are told work out 5x plus 2 is equals to 12. So we are supposed to work out the value of x. So we are supposed to work out value of x. Let's have it right here. We have 5x plus 2 is equals to 12. So to be able to find the value of x, the first thing that you're really supposed to do is to take this 2 to the other side. What usually imply by saying so is that we minus 2 both on the left and the right side. So if we minus 2 from this side, we are going to get 5x. But now on the other side, if we minus 2, we are going to have 12 minus 2. So that is why I will usually say that if this plus 2 crosses these brackets, or rather crosses the equal sign, it changes the sign from a positive sign to a negative sign. So that is an explanation of minusing 2 and minusing 2 on both the right and the left hand side. So it all matters with how you interpret that and how you understand it, but the concept is that we are subtracting 2 from the left and from the right side, such that when we subtract 2 here, add these 2 dies off and we remain with nothing, but on the other side we remain with 12 minus 2, which we can be able to simplify. And let's go ahead and simplify that. What we get here is a 5x, and then on the right side we have 12 minus 2. That's going to give you 10. Finally, you can divide by 5, divide by 5, and this is going to give you x is equals to 10 divided by 5. What's the value for that? That's going to give you x is equals to 2. And we have such a case? Yeah, we have it right there. And that is the required solution for that. So you're likely to get questions of this nature where you're supposed to get the value of x, the value of y, the value of a, and the value of different unknowns. But for this level, you just get to find the value of one unknown. But as you proceed on, you'll be able to also find the value of two unknowns. For now, let's proceed on. We are told that when the baby fell sick, her temperature rose to 39.5 degrees Celsius. What was her temperature in Kelvin? A very good question and a very common question. So this question is testing whether you know how to convert Kelvin to degrees or degrees to Kelvin. But here we get to apply one particular formula, and that is Kelvin is equivalent to degrees Celsius that we've been given plus 273. Plus 273. So we check. We want to convert these degrees to Kelvin scale. So what we pick is that we pick 39.5. That is the degrees that we have. And then we add 273. Since I don't have my calculator with me here, you can do 273 plus 39.5. Here you get 0.5. 9 plus 3, 2, carry 1. We have 7, 10, 1, 3. So here we get 312.5. But now this is in Kelvin scale. So do we have such a value here? Yeah, definitely we have it right there. And that is how you are supposed to work out that. Believe that that is something that you can be able to handle. So with that, let's move on to our question 11. We have it right here. Wow, I was actually waiting for such a question because this is a question that rarely misses in examination. So let's go ahead and check it together. We have 78 divided by 26 plus 7 times 13 minus 21. How are we supposed to go about this? Remember, this is a question that is testing you on board mass, whether you know how to apply board mass. So you see 78 divided by 26. Well, it could be possible to divide this directly but to be able to divide it in an easier way, you can put it in terms of numerator and denominator, such that you have got 78 divided by 26 like that, and then you have plus 7 times 13 minus 21. You see, there is a common error which is very interesting here that many students do usually make. They usually start with the simple things. They say, you see, it is very easy for me to do 26 plus 7, and then they start with that, and they have 26 plus 7, that is simple to do because that is 33, and then you find yourself writing 33. Or even another student will say, you see, I love minus. Minus is very simple. And then you pick 13 minus 21. You go directly and minus that, and you say 13 minus 21. What do we get there? We get an 8, and you simply write an 8 there. That is totally wrong. You don't start with what is easy, but you start with what appears first in the order of board mass. So in the order of board mass, what we do check first is whether we've got brackets in our question. Definitely we don't have brackets. We go on to the other part of, we don't have of. What about division? If you look keenly, we've got a division here. So we start with the division. So with this, you can use a way that you find to be much convenient with you. However, the easiest and the way that I find to be quite better is to try to simplify it just from the way it is. Like 78, you can divide by 2 to get 39. You can divide 26 by 2 to get 13. And you see, it has become a bit easy because 39 divided by 13, that is something that is a bit much doable. Why? Because you see, this 1 goes into 3, 3 times 3 goes into 9 3 times. So 39 divided by 13, that is definitely a 3. So we write a 3 there, and we have plus 7 multiplied by 13 minus 21. So let's go ahead and see what we're really supposed to do. So the second part here is multiplication. We are done with division, right? Yeah, we are done with division. So we go to multiplication. So multiplication, we are supposed to take 7 times 13. So this one you can do it somewhere. Like you say, you want to do 13 multiplied by 7. 7 times 3, 1, 2. 7 times 1, that's 7. You had carried 2, that's 91. So you go ahead and replace it right here. But now this 3 is going to remain there. And then you have plus, what you obtain here is 91, and then minus 21 like that. Amazing. So let's go ahead. Here we have addition sign. This is what we have. So we get to handle that. So we have 3 plus 91. That's what we are supposed to handle. What do we get once we do that? We get 94. Yeah, that's supposed to be 9. And then 3 plus 1, that's 4. And then finally we have minus 21. So back to our board mass, the final sign there is a subtraction. So we can go ahead and simply minus here. We have 4 minus 1, that is 3. And we have 9 minus 2, that's 7, 3. And actually, that is the required solution for that. And that is how you are really supposed to tackle that question. And if you are really able to follow that, to follow the board mass, then you should be able to get the question right for that. So let's move on to another interesting question right here. It is a word problem, and it is telling us that 3 bags of maize, 15 kg, 60 kg, and 120 kg respectively, have to be put in smaller bags of equal mass. What is the greater mass of each bag obtained without a remainder? So we have got some key terms here. That is, the first key term here is greater mass. Greater mass. Notice the word G, greater mass. and then goes ahead and tells us of each smaller bag obtained without a remainder, something that is not leaving a remainder, it must be a common multiple, and a common multiple, we write it as cm, or rather common multiple, like that. So therefore, what is the question is wanting us to find is to find a number that can be divided with these numbers that are here without leaving a remainder. Therefore, that number must be a divisor of these numbers. Therefore, it must be a common divisor. We call it CD, and it must be great. Therefore, the question is telling us to find the GCD. That is the greatest common divisor of these numbers. So let's go ahead and do that. So we have 15, we have 60, we have 120. All right. So normally, we usually start by checking at 2. Can 2 divide all these numbers together? Absolutely not. Why? Because 15 is already an odd number, therefore it cannot be divided by a 2. Therefore, we go on to the next number, which is 3. We check at these numbers. Are they all divisible by 3? Well, you see 1 plus 5, that is 6. 6 is divisible by 3. 6 is divisible by 3. 1 plus 2, that's 3. That 120 is divisible by 3. Therefore, all these numbers are divisible by 3. Therefore, we write a 3 there, and we divide 15 divided by 3. That's gonna give us a 5. 60 divided by 3, that's gonna give us a 20. 120 divided by 3, we get a 40. Amazing. We check again. Can 3 divide these numbers again? Unfortunately not. Why? Because 5 is not divisible by 3, same to 20, and also 40 is not divisible by 3. We go on to the next number, and that is 5. We write a 5 there. Yeah, because we see that 5 is divisible by all these numbers. So 5 divided by 5, we get 1. 20 divided by 5, that's 4. 40 divided by 5, that's an 8. So finally, we get that the GCD of this number is equivalent to 3 times 5. You write it there, 3 times 5. And what does that give us? That gives us 15. And that actually is the correct solution for that. Therefore, we just write it there, 15. So this was a very good question to check if you can be able to turn a word problem into a mathematical problem, which is a great skill. So right on our screen, what we have is a very interesting question as well, question 13. We are told that Miss Mooley spent 1/10 of her July salary on rent, and then 2/5 on food, 0/10 on transport, and saved 1/5 of her salary. You are told arrange the fraction on descending order. So two very important things that you're really supposed to know. Number one is comparing fractions. And the second thing is whether you know what it means to descend. So these are very important things that you're really supposed to know. So that question is just testing on these two things. So if you're able to figure out those two things, then this question should never be a trouble to you again. But I'm going to show you how you can make this question to be very easy, and how you can be able to handle it quite efficiently in a way that you'll be sure that you'll always get it right. So we have 1/10. These are the fractions that you're supposed to compare. 1/10. We have 2/5. We have 3/10. And finally, we have 1/5. Amazing. So we have them right like that. So let's get right into this. We have all these fractions the way that they are like that. So what you're really supposed to do is to check first the denominator of these numbers. You see, the denominator here is 10, 5, 10, 5. You see, it is not quite easy to compare these numbers the way they are because they don't share a common denominator. So the first thing to do is to convert them into a similar denominator. You see, if we have something like 2 over 10, there is something like it is the division of 2. It is just one division out of 10 segments of something that you have. But you see, if you can be able to convert them to a similar denominator, then it becomes quite easy to check which one is big, which one is small, yeah, and so on. So to be able to do that, we convert this 5 to a 10. But how can we be able to do that without altering the value of this fraction? The way that we do that is we multiply that by 2 over 2, such that we'll have 2 times 2 on the numerator and 5 times 2. You see, when you multiply something by 2 over 2, it doesn't change the value of that number. Why? Because 2 over 2 is similar to 1. You see, 2 divided by 2 is 1. Therefore, it doesn't change the value of that. This one is quite okay because the denominator is 10. Therefore, what we do to the final fraction, we multiply by 2 over 2 like that. And let's go ahead and solve this. So what we get right here is 1 over 10, just the same way it is 1 over 10. It doesn't change at all. And what we have here is 2 over 5 multiplied by 2 over 2. So we have 2 times 2, that's 4. And we have 5 times 2, 10. Followed by, we have 3 over 10 here. And here we have 1 times 2, that's 2. And here we have 5 times 2, that's 10. You see, it has become a bit easier for us because we can see that what we have right here is something that is a little bit much easier to handle and much easier to work with. Why? Because the fractions that we have, or rather the denominators of these numbers, are equal. We have 10, 10, 10, 10. You see, if we are to assume like we have got something that have got 10 divisions, let's say it's something like this, with the first division, second, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is to mean like what you're having here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So once you have 1 over 10, it's like you have this shape over here, 1 over 10. So it is 1 out of all these, like it's just one proportion. Saying 4 over 10, it's like saying that you have 4 proportions, 1, 2, 3, 4, and up to this point, right? That is right there. So to be able to check these numbers, therefore that would imply that this number is bigger than this number, and this 3 over 10 is bigger than 2 over 10, 2 over 10 is bigger than 1 over 10. So knowing that, we can be able to arrange it in a descending order. But what is descending order? Descending order, we need to know how to do that. So descending, that implies that we are going to start from big to small. That is what means to descend. To descend is like going down from big to small. So which among these numbers do you think is the largest? Between 1 over 10, 4 over 10, 3 over 10, and 2 over 10. Which one do you think is the largest? Definitely, I want to hope that your guess is correct because it is 4 over 10. So we pick 4 over 10 and we mark that we've already picked it so that we can make the work easier as we move on. So what's the other biggest number that remains among all these? It is 3 over 10. Therefore, we pick 3 over 10 and we write it there. And now finally we remain with 2/10 and 1/10. Which one do you think among these one is a bit bigger? Definitely it is 2/10. Therefore we write 2/10. And finally we have 1/10 there. We write it there. So this is how those numbers appear in a descending order. But now remember that, and this is actually one of the most important thing to remember, that now 4/10, you see, the part that we have here, it's important to know it well. You see this 1/10, it is equivalent to that 1/10. This 4/10, it is equivalent to 2/5. This 3/10, it remains the same way it was 3/10. And what we have here, this is 2/10. This one is equivalent to 1/5. So a very important thing that you're really supposed to know and also do as well, and that is to convert these numbers to their original format. Because if you leave it at this, it's not going to award you some marks because you never left the numbers in their original format. So this was just to help us to see which numbers are bigger, which numbers are smaller, yeah, and so on. So what we do now is now to convert these numbers to their original form. What was 4/10? 4/10 was equivalent to 2/5. What about 3/10? 3/10, it's just the same way it is. We have not converted it. What about 2/10? 2/10 was equivalent to 1/5. You see where my pointer is, therefore we write 1/5. And finally, this is 1/10. 1/10 was initially the same way it was here. And just to confirm that you did it correctly and that you've changed them to the original format, you check 2/5. Does it appear somewhere? Yeah, it is there. What about 3/10? It appears here. What about 1/5? Yes, it appears there. And finally, what about 1/10? It appears there. And you've arranged all of them in the order that is required, and that is the descending order. And that is how you're really supposed to tackle that. And with that, we can move on to our next question. Yeah, remember that what we are covering is a whole paper for grade 7. This is a standard mathematics examination. So we are told to work out, or rather to work out the square root of 12.96. Well, this is a very interesting question, and there are different ways in which you can be able to go about this. Yeah, but to be able to work out correctly with a lot of ease is to find out on how you are going to handle the decimal. For instance, you see what we have here is 12.96. How can we go ahead and handle this out? So we are having 12.96. 12.96. It's what we have right here with us. So what you're really supposed to do is pick up the number the way it is, that is 12.96, and then we convert it to a fraction. You see, if we convert this one into a fraction, it's going to be 1296 divided by 100, and then with that we can be able to find the square root of that. You see, this one is equivalent to the square root of 12.96 divided by the square root of 100. So let's go ahead and try to simplify this. To be able to find the square root of 12.96, it's not quite easy to find it directly, but we can use the factorization method where we pick the number 12.96 and then we start by dividing it by different factors. For instance, we divide by 2, we get 6. What do we get? 96 divided by 2. So 96 divided by 2, that should be 48 here. Divide by 2, we get 324. We divide by 2, we get 162. I believe that's right. We divide by 2 again. we get 8, 1. We can't divide by 2 again, so we divide by 3. And what we get here is 2, 7. We divide by 3 again. We get a 9, and we divide by 3. We get a 3. So what we are getting here is, in place of 1296, what we get here is 2. And then we have, how many 2s are these? 1, 2, 3, 4. There are 4 of them, so we can write it like that. And then we multiply by, we have 3 here. So how many 3s are these? We have 1, 2, 3, 4 of them. And then remember that this is the square root. So you see 1296 is equivalent to 2 to the power 4 multiplied by 3 to the power 4. But remember, we've got the square root of 100 like that. So this one, we might not need it as much for now because we have been able to express 1296 in terms of its factors. So we go ahead and work out with this. So what you're having is the square root of 2 to the power 4 multiplied by 3 to the power 4, the square root of that over the square root of 100. So let's go ahead and simplify this. We have 2 to the power 4. So to be able to find the square root of this, what we usually do is that we usually divide the powers. So we divide the power by 2. We also do the same to the other power. This is 2 to the power 4. We just divide that power by 2. And here, this is quite easy to do. That is the square root of 100. We know that that is equivalent to 10. Therefore, we write a 10 there. So what we have here is 2. And then we have 4 divided by 2, that is 2. And then we have multiplied by 3. And then 4 divided by 2, that is 2 over 10. So what we have here is 2 to the power 2, that's 4, multiplied by 9 over 10. So what we get here is 9 times 4, that's 36, divided by 10. So 36 divided by 10. That is something that you can be able to do because we just shift this decimal to here and we get 3.6. And actually, that's the correct solution for that. And that is how you are supposed to solve about that question. I believe that if you get any question of this manner, then you should be able to find its solution correctly. So let's move on to our next question. We have question 15. We are told that the 3 sides of a triangle are shown below. Find its perimeter. So there is an error that I saw, or rather many students do usually make whenever they have got such a question. I'm going to show you quite shortly, but before then, let's find out on how we are really supposed to work out that. What you are really supposed to know about perimeter is that perimeter is the sum around a shape. So it is the sum of the length around a shape. So we are supposed to take everything the way it is. So if it is x plus 5, we pick it x plus 5, and then we have that we add to x plus 5, and then we add to 2x plus 1. So once we have something like this, we can put the like terms together. For instance, we see that we've got some x in different places. For instance, we have this x here, we've got an x there, and we've got some 2x there. Therefore, we put them together to have x plus x, this one plus 2x, and then plus, do we have anything else? We don't have any other x, so now we pick the numbers. We have a 5, and a 1. So therefore we go ahead and add the numbers together. We have 5 plus 5 plus 1, like that. So we have x plus x, 2x plus 2x. That's going to give you, for x, this is like 1x plus 1x, that is 2x. you have 2x plus 2x, that is 4x. And finally, for the numbers side, we have 5 plus 5, that is 10, and 10 plus 1, that is going to give you 11. And that is the required solution for that. But here is where the error comes. You'll find, because you are not maybe used to work out with these variables, that is x, you'll find like there's a person who will pick and say that the perimeter is 5 plus 5 plus 1, and this is totally wrong. Why? Because you never included all the values that are there. Therefore, it is important that as you work out this, you always remember to include all the values that are given, so that you are able to work out it correctly, and so that you are able to get the solution for your question. But having that, we also have a good question here for our practice. Question 16, we are told, work out the area of the figure below in hectares. In hectares. This is very important, and also this is very important. So what we ask ourselves is, how do we find the area of a rectangle? This is of a triangle. This is a triangle. How do we find the area of a triangle? We say that the area of a triangle is equivalent to a half base times height. Let's go ahead and work out that. So we have it right here with us. So we have a half multiplied by the base. What's the base? That's 600 meters. And then we have the height, that's 800 meters. And by the way, can you run for 800 meters marathon? Well, that's a discussion for another day. So we have a half, so we divide by 2 to get 1. We divide by 2 to get 300 meters right there. So what we get here is 300 meters multiplied by 800 meters. So the easiest way to do this kind of multiplication, that is involving many zeros, is that we are supposed to pick this 3 multiplied by 8, that is 24, followed by the number of zeros that are here. How many zeros are here? 2. What about here? Another 2 zeros like that. So it is going to be 240,000 meters squared. But then we have to convert this one into hectares. But how do we do that? To be able to convert that to hectares, we pick it the way it is, that is 240,000, and then we divide by 100 multiplied by 100 hectares. And the value that you are going to get here, it is going to be in terms of hectares. Let's go ahead and do this division. So we have divide by 0, 0, divide by 10, divide by 10, divide by 10, divide by 10, like that. So we have 1, 2, 3, 4, 1, 2, 3, 4. So finally, what we remain with here is 24 hectares, like that. And actually, that is the required solution for that, and that is how you are really supposed to work out that. Very important. So you see, we've dealt a bit with area. Let's now deal a bit with some finances and calculations to do with money. And we have a question that is asking about that. We are told that a salesman is paid a basic salary of shillings 10,000 and 10% commission on the value of goods sold. The question goes ahead and tells us that in 1 month he sold goods worthy shillings 200,000. What were his total earnings for that month? What was his total earnings that month? So how are we really supposed to work out this, and how are we really supposed to solve out this? Because you see that we have the commission, and we have the goods that were sold, and also together with also a basic salary. So what you are really supposed to know is how to calculate the total earnings. So to calculate the total earnings, what you're really supposed to do is that you are supposed to take the basic salary, let's abbreviate it as BS, that is basic salary, and then you add commission. And you add the commission. Therefore, the total earnings will be the basic salary, which is 10,000. And then you add the commission. The commission is 10%. 10%, you see, the word percent means 10 out of 100. The word percent means out of 100. Therefore, it is 10 out of 100 of the value of goods sold. What is the value of goods sold? The goods sold were worth 200,000. Therefore, it is multiplied by 200,000 like that. So with that, we can go ahead and work out that. So we have 10,000. It doesn't change as much, but for this one, we can go ahead and simplify. We have divide by 10, divide by 10, divide by 10, divide by 10 there. So we get plus. Actually, here is a good way to write numbers to ensure that you will minimize the chances of making errors. So whenever you are writing a number, always try to put it in terms of threes, that is from the right side. Like for instance, here we are supposed to have how many zeros? 1, 2, 3, 4 zeros. So you can write in such a way that there is a small space between the first zero and the zeros that follow, so that you can see clearly that this is 20,000, such that you can easily work out 10,000 plus 20,000 and say that that is equivalent to 30,000. And that is exactly how you are really supposed to tackle about that. But the most important thing is to understand how to calculate the total earnings, which is basic salary plus the commission, and also to ensure that you work out your calculations correctly in such a way that you do not make any error in that. Another question, actually we've not yet done any question to do with distance, speed. Yeah, but this is a good question for that matter to cover up on that. So we are told that a motorist drove a distance of for 80 kilometers in 6 hours. And then the question goes ahead and tells us what is the speed in meters per second. What is the speed in meters per second? Well, this is a bit quite amazing because it is asking us to find the speed in meters per second. So there are different ways in which you can calculate this. One, you can start by changing all these figures in terms of meters. If it is kilometers, you change them to meters, and then if it is now the hours, you change it now to seconds. Yeah, so that you are able to calculate that. So it all depends with the way that you find easier and convenient. Yeah, but for this particular example, we can start by converting this one for 80 kilometers into meters. And what we do there is that we divide, that is distance. We have it as for 80 kilometers. We say that that one is equivalent to for 80. We multiply by 1,000 to get it in terms of meters. And what do we get here? We get for 80,000 meters. What about time? Time is in 6 hours. So you can convert this one also. But how do you convert that? You convert that by saying that you have 6 hours. So you first convert the 6 hours to minutes by multiplying by 60, and then you multiply by 60 again to get it in seconds. And what do you get once you do this? You have 6 times 6, that is 6. That is 6 times 6. What do you get? I don't have my calculator around, but this is 6 times 6, that is 6, 6, 3, 18 plus 3, 21. That is 216,000. 216. This is 216. But here we have how many zeros? This is 2 zeros. So it is just 216 100 seconds like that. we might not need to have this, so we remove it like that. So we go ahead and find what the question is telling us to find the speed. How do we find speed? Speed is equals to distance over time. So I'll show you how to always remember this very shortly. But we have distance over time. And what is our distance? Our distance is for 80,000. You see, this is for 80,000. So we are dividing that with 21600. 21600. So we have divide by 10, divide by 10, divide by 10, divide by 10. Yeah, we have it like that. What about for this other part? What we have here is now 4800, and now what we are having is 4800. So we are supposed to divide that with now the denominator that we have. And what's our denominator? That is 216. 216. So you can try to simplify this a bit by dividing by common terms. Do we have any common terms here? I believe it's possible to do that. You can divide by 2. Let's divide by 2 here. You get 108. 216 divide by 2. You get 2400. Can we divide by 2 again? Yeah, we can divide by 2 to get 1200. Divide by 2, or do we get 54? Yeah, 54. Divide by 2 again, we get 600. Divide by 2, we get 27. Okay, can we divide by 2 again? No, so we simply divide by 3. Dividing by 3, we get 200. Divide by 3, we get 9. So we have 200 over 9. Can we be able to divide that any further? No, it's not possible to divide this any further. So what we can do is that we can convert it into an improper fraction by doing the long division. So if we are to divide this using the long division like this, you should be able to get, here we have 20 divided by 9, that is 2. We have 18, so you get 2, 20, and then you'll get a 2 here because of 18, so you'll get 22. And here, once you minus 20 minus 18, you are going to get 2 over 9. We might not need to have this for now. And finally, we indicate that the solution that we get here is now 22 2 over 9. And now remember that that one is in meters per second. So that is how you are really supposed to work out that, and that is how you are supposed to solve that. And once you do that, then you should be able to get all your full marks for that question. So we've not dealt with some shapes, but I see that we have a question here that is dealing with polygons and shapes. So let's get into it. Question 19, a pentagon is a polygon with 5 sides. We are told find the number of triangles and hence work out the sum of interior angles. So that is a question that we are really supposed to solve and to work out, and it's actually a very good question for our practice, especially to do with shapes. So actually, if you wish, you can try to think through it and to try to figure it out on your own, whether you can be able to work out the number of triangles that you can be able to get from a pentagon, and also at the same time whether you can be able to work out the sum of the interior angles. But then let's get to work it out together. So a pentagon is a shape, or rather pentagon is a polygon with 5 sides. So we need to have it so that we can be able to visualize it well. So a pentagon looks something. It's kind of like a house, because like the old hats, because you see this is the first side, second, third, fourth, fifth. Yeah, it have got 5 sides. So how many triangles can we be able to get out of this? Because that is the first question. How many triangles? So you see, if we can divide this one, let's pick any point. I don't know which point you'd like us to pick. We can pick this point over here, and then we extend a line like that, and then we extend another line like that. So you realize that the number of triangles that we get, it is this one, the first one, second one, and third one, like that. So the number of triangles are 3 of them. So the other part is work out the sum of interior angles. Interior angles. Interior angles. That's what you are supposed to work. Interior angles. Now we work out their sum. How are we supposed to do about that? We well know that you see, for instance, each and every angle is covering the each and every triangle is covering an angle that is towards its edge. Therefore, what you're really supposed to know is the sum of angles in this triangle, because if we add this angle and this angle and this angle, this is going to give us 180 degrees. We go ahead, we have this angle and this angle and this angle. All these 3 angles are going to give us 180 because they are inside one triangle. And finally, we have this angle and this angle and this angle. So if we add that, it is going to give us 180. Therefore, to find the sum of the interior angles, we simply take 180 multiplied by 3, but then we know that 180 multiplied by 3 is equivalent to 180 plus 180 plus 180, and this is equals to 180 plus 180, that's 360. 360 plus 180, you can work out this, that is 360 plus 180, you have 0, you have 8 plus 4, you get a 4, you carry 1, you have 3, 4, 5, 540. So this is equivalent to 540 degrees. And actually, that is how you are supposed to solve that question. And actually, that is the required solution for that. I don't know if we have got any other more questions beyond this. Oh yeah, we have got about 3 more questions right here with us. And we have another question, but it is asking on a different concept on angles. And we are told that find the value of the angles marked with the letters. So we have this one is 120 degrees. We have K, we have P, we have L, we don't know what those are. And now here we have, this is parallel when we have them like that. So we are supposed to find this angle, this angle, this angle. So we can start by finding the angles that we don't have. And like you see, this is a straight line like that. And the angle that is here is 120. So let's have this like this. This is the shape that we are having here, such that this angle is 120. Can we be able to get this angle that is here, this one? This one. It is this one. So the way that we're able to get it is we pick 180 minus 120, and that is going to give us a 60 degrees, and we have it right there. That is 60 degrees, like that. So we have this angle here. This is 120. You see, angle K is vertically opposite this angle. Therefore, you see this angle here, it should be equivalent to this angle right there, because they are vertically opposite. Therefore, that should be 120 degrees. What about this one? You see this one, this is 60 degrees. This angle, it should be equivalent to this angle that is here. It should be 60 degrees. Why? Because they are vertically opposite angles. Let's go ahead. Can we be able to find this angle? Yeah, you see this angle here, 60, it is on a transverse with this angle that is here. With this angle that is here. Therefore, this angle that is here should also be equivalent to 60 degrees like that. And you see this one? It is on a transverse with this angle that is right here, this one. Therefore, this angle is equivalent to this one over here, and that should be 120. And L is vertically opposite, therefore that should be 120 degrees like that. Is there any other angle that we have not yet solved for? I believe that we have worked out the angles that we are supposed to work out for. So finally what we do is that we bring them together. That is, we are supposed to find the value of K, P, and also L. And what do we get for K? We get it is equals to 120 degrees. For P, where is P located at? This angle, it is 60 degrees, and L is 120 degrees like that. So that's the required solution for that, and if you can be able to do that, then you should be able to get all the full marks for that, and that is how you are supposed to do. So on to this question. Wow, this is wonderful because we have not yet dealt with a question to do with bar graphs and pie chart. Yeah, but this is a good representation of such. So we are told the circle graph shows how Mary spent her salary of shillings 30,000. We have the circle graph here, what we call the pie chart. We have entertainment 108 degrees, rent 72 degrees, savings, it's not given, 60% food. And then question A, we are told calculate the degrees of savings. Where is savings? This angle here. So to be able to calculate this angle here, what you are supposed to know is that the total degrees in this circle is 360. And to be able to get this particular angle, we should minus each and every angle that is there so that we can be able to get the remaining angle. So we minus the sum of these other angles, that is 72 plus 108 plus 60, like that. So we get 360 minus, you can be able to work out this because you see 72 plus 8, that is 80, and this is 100, so this is 180. 72 plus 108, that is 180, and then you have plus 60. 180 plus 60, what do you get? You do this 180 plus 60 like that, you get a 0, 8, 4, like that. So that's something that you can be able to work out, and you get 240. So let's go ahead and do this minus. We have 360, and then we are minusing 240. So this is like 0 minus 0, that is 0. You have 6 minus 4, that is 2. You have 3 minus 2, that is 1. Therefore, you get 120 degrees. And actually, that is the solution for that. So we go ahead and find out what the question is asking us beyond that. We are told how much money did he spend on rent. Let's go ahead and calculate that. So from what we have here is that the proportion that went to rent is 72 degrees. Therefore, that is 72. And now remember that degrees, all the degrees here total up to 360. Therefore, this is 72 out of 360. And we multiply by the figure that we have here, which is 30,000. Can we be able to work out this? Yeah, I believe we can, because we divide by 10, divide by 10, divide by 2, or rather divide by 36, we get 1, divide by 36, we get 2, and finally we have 2 multiplied by, this is 3000. 2 divided by 2 multiplied by 3000, that's going to give you 6000. And that is the required solution for that, because we've now been able to deal with the two parts. But the most important thing to remember that as you tackle this question is that always know that the total number of degrees here add up to 360 degrees, and then be a bit careful as you work out the calculations for this. Let's move on to our final question. Yeah, for this particular paper, this is supposed to be question 22. Yeah. This is good. We have not yet dealt with capacity and volume, but here is a good question to help us in that. We are told, find the capacity of the cylinder below. And the cylinder we have it right here. This is 30 centimeter to represent height, and 7 centimeter to represent the diameter. How do we find the capacity? Capacity, we find it. This is almost similar to finding the volume of the cylinder, and the volume of the cylinder we get it by pi r squared multiplied by height. Therefore, it's very important to always remember this formula for finding the capacity or the volume of a cylinder. But let's go ahead and solve this. So the pi, because we have not been given, we simply use the default one, which is 22/7 multiplied by the radius. You see, what we have here is diameter, which is equals to 7 centimeter. To get the radius, we divide the diameter by 2. Therefore, the radius will be equivalent to 7/2 centimeters. Therefore, we multiply by 7/2, multiply by 7/2, and finally multiply by the height, which is 30 centimeters, like that. So this is how we are supposed to go about that. So once we have that, we try to simplify it in order to find the final solution for that. Luckily enough, here we've got a 7, we divide by 7, we've got a 7, divide by 7, divide by 2 there, divide by 2, we get 11, divide by 2 there, we get a 15. Finally, what do we get? Which values remain? We remain with 11 multiplied by 7 multiplied by 15. Well, this is quite straightforward to do. That is 11 times 7. We get a 77 multiplied by 15. So we have 15 multiplied by 77. You can try to work out that such that you'll have 7 times 5, 35, 5 carry 3. We have 7 multiplied by 1 plus 3. That's 105, and 105, like that. And then you sum up this. This is becoming 11555. 1155. But we might not need to have that, so we put it away. And the value that we get here is 1155. And we remember the values is in centimeter cubed, because you are likely to forget and put here a squared, which is totally wrong. Capacity is in cubic units, therefore it must be cubic, like that. If you've just been told to find the capacity, you will just give it in terms of centimeter cubed. But then if it was asking about the volume, then we could have gone to an extra step of trying to convert this one to liters and so on. But for this one, it is satisfactory to leave it at that, and that is how you are really supposed to do that. So this is a very wonderful paper to practice with, and it was a good paper getting to work on it, and that is how you are really supposed to go about that. And those are the solutions for that. You can take some time if you wish to go through it over and over again to be able to understand the concepts that you may have missed, and also to ensure that you fully comprehend on all the areas. So remember that this is Competency Mathematics, where we make mathematics easy. So keep uploading more and more tutorials, to just continue making mathematics fun, enjoyable, and also at the same time easy. Until next time, bye bye for now.